Now we're going to take a look at torque. Torque is a quantity that measures the ability of a force to rotate an object around some axis. So how easily an object rotates on both how much force is applied and where the force is applied. So when we apply force over a certain lever arm, we'll get a certain amount of torque. And so this looks like, if you have a door hinge here, let's say here's the door, and you push on the door right here at a 90-degree angle with a certain amount of force. And let's say this is 2 meters long, and let's say 10 newtons of force. We would have here a force of 10 newtons times the displacement of 2 meters times the sine of 90. Sine of 90 is 0, and we would get 20 Newton meters as our torque. So if we look at this hinge here, we have FB that's being applied closer to the hinge, and then we have FA that's further from the hinge. And so, if we look at the torque involved, force times the lever arm times sine of theta, which one's going to produce more torque if the force is the same? So, RA, this lever arm from here to here is greater. So this would enable you to have more torque. And you can try this if you have a hinge, like even at the door at your house. You can push right here real close to the hinge, and you're not going to get much torque. You're not going to get much rotation. But if you push at the end of the door, you'll get much more rotation. The sign of torque is important because torque is a vector quantity. And for our conventions, we're going to use positive torque if the rotation is counterclockwise and negative torque if the rotation is clockwise. So in this case here, if we had this door and we applied a force here and it rotated this way counterclockwise, we would call that positive torque. Okay. All right, so in this one, we have a door that's 36 inches wide. The doorknob is 32 inches from the hinge, and we want to calculate the torque a person applies when he pushes on the doorknob at right angles to the door with a force of 110 newtons. So the first thing we'll need to do is convert our inches into meters. And so inches into centimeters there, centimeters into meters. So those are going to be our two forces. So what I want to have you do is go ahead and you can pause the clip and calculate the torque at the doorknob. Go ahead and calculate the torque at the edge of the door as well, and we'll compare the two. So go ahead and hit pause and do that, and then you can hit play to continue. Okay, so in this case, with 110 newtons at the point 8128 meters, we get a torque of negative 89.408. That's because the torque, right, is going this way, clockwise, and clockwise is negative torque. Pushing at the edge of the door over here, we get more torque, right? And it's also negative, and that should make sense because if the hinge is here, we're going to get more torque with a greater lever arm. Here's a couple pictures of examples where torque is being applied, and you can see with this wrench how long the lever arm is. Let's say the person grabbed the wrench right here, right? They're not going to get as much torque by, if this was triple, you get triple the torque, triple the lever arm there. So, if you've ever taken a bolt off a car, you know how helpful these are as well. You have a nice long torque, and you're applying the force. In this case, 90 degrees to it. In this case, 90 degrees to it to make the torque go. So if we look at these three, forces, and we try to figure out what the torque is for these, you'll notice that we've got one at an angle here, FC, and then we have one that's being pushed at the door. Obviously, FA is going to cause torque, right? It's at 90 degrees. FC, part of that will cause torque, but part of it won't, right? Because you're pushing it. The portion that's pushing it, vertically here will cause torque, but The horizontal won't. And then FD, right? You're just pushing straight on it. You're not getting any torque there. That would be sine of 0 degrees, which is 0, and you wouldn't get any torque. So if we look at this situation here, let's say we have a force applied of 35 newtons at this hinge here. What we have to make sure is what's going on with the angle. And so what we need really, right, if we have this force at an angle, what we really need is this portion right here, which I already included there. Because this portion of FA, right, if we break down FA, if this is FA, only this portion, the vertical portion here, is doing any torque. So in our trig, we have to make sure that works out. Sine theta equals opposite over hypotenuse. So the opposite side is here. The adjacent side is here, right? And so, or not the adjacent, the hypotenuse is here. So when we look at the torque equation, we have to be very careful with that. So in other words, which part of, in this case, which part will actually do, do torque? And it's, again, only this portion right here will do torque. So what angle do we actually need? We know we need this part. So if we look at the sine of theta assumes the interior angle here. So when we look at torque and we calculate torque, that would be force times displacement times sine of theta. In this case, we need 60 degrees, not the 30 degrees right here. We need the 60 degrees because it's the opposite side. It's assuming the opposite side right here, which is right here, right? Assuming the opposite side, this is what we need right here. So if you're given a force and an angle, be very careful before you do the rest of the work, because you have to make sure the torque works out. And when we do that, in this case here, the force is 35 newtons, the lever arm is 2 meters here, and we get a torque, a clockwise torque of negative 60.62 newton meters. Okay, so in this one here, the force is 25 newtons. The angle theta inside here is 55 degrees. The arm length is 1.4 meters. So what I want you to do first is draw out the triangle, use the sign, make sure that the trig works out, and then you can calculate the torque for this situation here where the force is in an angle. So go ahead and hit pause and try that, and then when you're ready, you can hit play to continue. Okay, so the trig works out. This is the opposite side is what we need, and that's the angle that we're given there. And we end up getting a torque of negative 28.67 newton meters because it's going to rotate clockwise, and we get negative torque with clockwise.